Let us understand the AVL rotations. We perform rotation in AVL tree only in case the balance factor is other than -1, 0 and 1. There are basically four types of rotations which are LL rotation, RR rotation, LR rotation and RL rotation. Consider a node A as the node where the balance factor deviates from -1, 0 or 1. The first two rotations, that is LL and R, are single rotations, while the other two, LR and RL, are double rotations. For a tree to become unbalanced, its minimum height must be at least 2. Let's explore each type of rotation. RR rotation. When a binary search tree becomes unbalanced due to a node being inserted into the right subtree of the right subtree of node A, an RR rotation is performed. This is counterclockwise rotation applied to edge below a node with a balance factor of -2. In the example, you can see node A has balance factor of -2 because node C was inserted into the right subtree of A right subtree. To restore balance, we perform RR rotation on the edge below A. LL rotation. When a binary search tree becomes unbalanced due to a node being inserted into the left subtree of the left subtree of node C, an LL rotation is performed. This clockwise rotation is applied to the edge below a node with the balance factor of 2. In the example, you can see node C has a balance factor of 2 because node A was inserted into the left subtree of C's left subtree. To restore the balance, we perform LL rotation on the edge below C. LR rotation. Double rotations are more complex than single rotation. As previously explained, an LR rotation involves performing an RR rotation followed by an LL rotation. This means we first apply RR rotation to ensure subtree and then perform an LL rotation on the entire tree. This means we first apply an RR rotation to a subtree and then perform LL rotation on the entire tree. Here the entire tree refers to the first node along the path of the inserted node that has balance factor other than -1, 0 or 1. Let us understand each and every step very clearly. A node B has been inserted into the right subtree of A left subtree of C, because of which C has become an unbalanced node having balance factor 2. This case is LR rotation, where inserted node is in the right subtree of left subtree of C. As LR rotation is equal to RR plus LL rotation, hence RR, that is anti-clockwise on subtree rooted A, is performed first. By doing RR rotation, node A has become the left subtree of B. After performing RR rotation, node C is still unbalanced, that is having balance factor 2, as inserted node A is in the left of C. Now we perform LL clockwise rotation on full tree, that is on node C. Node C has now become the right subtree of node B. A is the left subtree of B. Balance factor of each node is now either 0, -1 or 1. That is, binary search tree is balanced now. Let us understand the RL rotation. As previously mentioned, double rotations are a bit more complex than single rotation explained earlier. An RL rotation involves an LL rotation followed by an RR rotation. This means we first perform the LL rotation on the subtree, then an RR rotation on the entire tree. Here, entire tree refers to the first node along the path of the inserted node that has a balance factor other than -1, 0 or 1. A node B has been inserted into the left subtree of C, the right subtree of A, because of which A has become an unbalanced node having balance factor -2. This case is RL rotation, where inserted node is in the left subtree of the right subtree of A. As RL rotation is equal to LL rotation plus RR rotation, hence LL, that is clockwise on subtree rooted at C, is performed first. By doing RR rotation, node C has become the right subtree of B. After performing the LL rotation, the node A is still unbalanced, that is having balance factor -2, which is because of the right subtree of node A. Now we perform RR rotation, that is anti-clockwise rotation on full tree, that is on node A. Node C has now become the right subtree of node B, and node A has become the left subtree of B. Balance factor of each node is either -1, 0 or 1. That is binary search tree is balanced now.